Alright, so let's talk about the scientific method, which should be at the ending of chapter 1. And the scientific method, there are two schools of thought. The first one is deduction, which Sherlock Holmes is a good example of, and induction. Induction would be Dr. House. And so when you look at these two schools of thought, you can see that they vary slightly. With Sherlock Holmes, he would start off with a theory. Now, somebody is going to come to him. They're going to tell him, oh, somebody stole jewelry from the store next door. So Sherlock Holmes is not going to actually see that the jewelry was stolen. He's just going to hear about it. And so that's why it starts off with a theory. And then from there, he has to come up with a hypothesis based on the information that he was given. So, for instance, he will probably be like, all right, I think the guy that I saw walking very suspiciously down the road, I think he is the one that stole the jewelry. So he'll make that statement, and then he will go out and collect data, basically his observations. And once he collects enough observations and he can prove his point, then he proves his theory. Now let's look at Dr. House. And Dr. House will start off with an observation. So he'll have a patient that comes into his hospital claiming to have a rash on his arm. And Dr. House will look at the patient's arm and say, yes, that patient has a rash on his arm, and will prescribe medication. But over time, if too many patients come in to the hospital with the same rash on their arm, and then Dr. House will be like, there might be a pattern here. What's going on? So Dr. House will do some investigation, but he will come up with a theory, a hypothesis about why all of these patients are coming in with rashes on their arms. So he will go out, do an experiment, and figure out what is causing the rash on the arm. And once he collects his data and reviews it, he'll be like, oh, the rash is coming because people are all eating at the same restaurant and they're eating contaminated food. And so then from there, he will turn his observations into a theory and he will confirm his hypothesis. Otherwise, he will have to go back and redo his hypothesis. So let's look at the scientific method. Now, scientists nowadays will use the induction method, similar to Dr. House, and won't be using the deduction method because, generally speaking, scientists will make an observation of a phenomenon in nature, and generally speaking, they won't come up with it on their own. They'll generally observe it. And so here you can see Calvin and Hobbes doing demonstrating the first two steps of the scientific method. You'll see that Calvin tells Hobbes that when he puts this slice of bread into a toaster and pushes the lever down, it pops up in a few minutes as toast. And so then Hobbes goes, where does the bread go? And Calvin's like, who knows? Isn't that weird? So when he makes that observation that the toast pops up, that's step one. He observes something. And then when he says, where does the bread go? That is step two in asking a question. So here are the steps of the scientific method. You have to make an observation first. Then you ask a question. Then you form a hypothesis. It has to be a statement about the observation that can be experimented on. And then you create your experiment and you collect data for your experiment. And when you review the data, you will either accept or reject your hypothesis. And if you did not get the results that you wanted, then you'll have to go back, redo your hypothesis, and do the experiment all over again until you get somewhat of a result that you wanted. All right, so what is a hypothesis? A hypothesis is a statement or an explanation of a phenomenon or an observation that can be tested or disproven. So this is a key word here. It has to be testable. If you cannot test your hypothesis, then it is not a hypothesis, it is just a statement. And if we look at this comic strip right here, you can see this girl is convinced that jelly beans cause acne. And so she sends her scientist friends over to investigate, and they find that there is no correlation between jelly beans and acne. So she stands there and she thinks about it, and she wonders if it's possibly a particular color that causes acne. So she sends her scientist friends to go and investigate it. So let's look at a more ocean-related example. So here on the left-hand column, you can see the general hypothesis that is stated is that all fishes have gills. So when you go through your testing, you'll see that yes, all fishes in the ocean have gills. And on the right-hand side, you'll see another hypothesis that states all marine organisms have gills. Now, if you go through the testing on that hypothesis, you'll come up to the result that no, not all marine organisms have gills. Whales, for instance, do not have gills. So, and you'll see that other marine organisms such as clams, lobsters, seals, they all do not have gills. So it's really important to be very specific when you create your hypothesis. If it is too general, such as the one on the right-hand side, then you won't come up with a favorable result, and you have to go back and redo your hypothesis and your experiment. So there'll be times where you're testing a hypothesis, but there could be alternative hypotheses that you may want to test at the same time. That way you don't go back having to redo your experiment a number of times. Experiments are time and money, and you don't want to be wasting your time or your money redoing the same experiment over and over again. So a lot of times you will do your experiment once, and you will test a number of different hypotheses. And so in this case here, the jelly bean example, you can see this experiment was done a number of times with all the different colors of the jelly beans. And when you look very closely at the comic strip, you can see all but one did not have a result. The green jelly bean, however, did have a result and actually caused acne when given to people. So when you do your experiment will be based on a number of variables. Now, when you want to look for a specific variable, such as the jelly bean example, you only want to change one variable at a time. You don't want to be changing multiple variables, because then you won't know exactly which one causes the result. So in this mussels example, they want to see if the water temperature causes the mussels to grow at different rates. And so the only variable here that will be changing is temperature. Everything else, like mussel type, food, water quality, and even diseases will all be held constant, will be the same. So both batches of mussels will get the same food, they will get the same water quality, they should have the same type of diseases if they have. And then there's also these unknown factors. These unknown factors you can't plan for. You won't know what they are until the very end, usually. And you just try to control them as best as you can. So then once you finish your experiment and you get your results, then you look to see what you got and if it was in line with what you were expecting. Now, you don't want to be like these scientists here, and you don't want to be listening in on dolphins speaking Spanish and not knowing what they're collecting. They're just collecting results. Okay? So it's really important to know what results you should be expecting, because once you get to this point, you shouldn't be surprised about what you get. And if you are, either you came up with something really awesome, or you need to go back and redo your hypothesis. And then finally, you'll have conclusions. And so based off of your results, you will conclude whether your hypothesis was correct or not, whether you proved it or disproved it. And In this case, the green jelly bean caused acne. So they were 95% sure that that green jelly beans cause acne when given to people. So the scientific law is a well-tested explanation of some sort of phenomenon that happens. It is also supported by a hypothesis. And much like Einstein's theory of relativity, it's not something that you really observe readily, or it's very difficult to observe. And so that's why it becomes a law, or the law of gravity, right? You don't really see gravity, but you know it's there. Likewise, unlike a theory, which is also well tested, and it's an explanation of some phenomenon that happens, and it is supported by a hypothesis, but it isn't a hunch or a guess. So a law could start off as a guess or hunch about something that happens, but a theory will never be that. It is something that is definitely something that happens, and definitely something that is tested over and over by multiple people. So the theory of plate tectonics, that is a proven theory that has been shown. Nowadays, we have GPS that can actually show us the plates moving at a very slow rate. But back when the plate tectonics was proposed, they didn't have such equipment, so you really had to have your data and your results really tied up well in order to be able to prove these things. Now, lastly, scientific proof. I have an image of the Little Mermaid here, and the reason why I have this is because, do you think the Little Mermaid is real? Do you think mermaids are real here on Earth? And if you answered no, well, are you sure about that? And have you actually seen a mermaid? Most people would say no, right? But just because you haven't seen a mermaid doesn't mean that mermaids aren't real. So let's look at this shark here. Do you think the shark is real? Have you all seen sharks in the aquarium or out in the wild? Majority of the people would say yes, right? I'm sure you guys said yes. But are you 100% sure that was a shark that you saw? Could be a whale. Could be something else. Could be some sort of other fish, not necessarily a shark. So the purpose of the scientific method is to state that you can't, with 100% certainty, prove that something is or isn't. So even though you guys all said that the Little Mermaid does not exist, you can't say with 100% certainty that she doesn't exist. Maybe there is the existence of mermaids and we just haven't seen them. But because we haven't seen them, that doesn't mean we can say no, they don't exist. And likewise with the shark. Even though majority of us have seen sharks before, we can't say for certain that they are actually sharks. Who knows? They could be aliens. No, not really. Anyways, so this is the ending of chapter 1 and module 1. So we will continue next week on to chapter 2, plate tectonics.